One-step equations, the basics. What should you know? Think of an equation as a balance scale with objects on both sides. The golden rule of solving equations is whatever you do to one side of the scale, you must do to the other. Okay? Whatever you do to one side of the equation, you must do to the other. Let me show you a visual because I'm big on visuals and it makes way more sense with a visual. All right, so you have a scale here. And just suppose we start with nothing on the scale. Okay, it's balanced because the left and right side are equal. Okay, there's an equal amount of zero weight on both sides. Now, if I were to put a block or a box on the left side, notice that the scale becomes unbalanced because I didn't do to the right side what I did to the left side. It's only until I do the same operation to both sides of the scale or equation that I get a balanced level scale. All right, if I add 1 to the left side, I must add 1 to the right side. That is the golden rule of solving equations. Never forget that. All right, so let's create this situation. I have 3 boxes on the left side of my scale. I have 6 items on the right side. Let's take a look at our scale here. We're going to create a new problem. Don't worry about, oh shoot, don't worry about what this means right now. And I messed that up. All right, so I want you to think of variables like x as boxes that contain items or could contain items. Now, right now the scale's unbalanced, and as I add more and more items, I'm waiting until it becomes balanced. There we go. The scale is now balanced, which tells me that 6 items is equal to 3 boxes. So whatever these items are, maybe they're cans of soup, and these are all boxes that would fit the cans of soup to be shipped somewhere. We can use this analogy now to figure out how many cans of soup would go into each box. All right. Now, when you stack the items in a certain way, it can be really obvious what the answer is. You can see that there's 3 groups of 2 here, so each box would fit 2 items. Well, it's not always obvious in math that how numbers break up because they're not visual necessarily. Numbers do not create an image. You have to create the image yourself. So 6 is usually just written like this, the number 6, or you can think of 6 ones all added together. But both of those ways of representing the number 6 do not make it clear and obvious that you would have 2 in each box. So you have to do some operations to kind of break it up. Now, if it wasn't broken up into groups, if you're a visual learner, you can break up the ones into groups. But if it's not, then we have a mathematical way to solve these types of problems. Now, there's a couple ways to do this. All right. One way to do it is to mathematically, so we have 2 ways of solving every problem. And you have a visual way and you have a mathematical or algebraic way. And so let's say we have 3x equals 6. All right, I want you to think of anytime you see x as boxes. All right, so we're going to find some boxes here. And we know we have 3 of them. 1, 2, 3. All right, I'm a big visual learner, so if you are, I hope these visual analogies will certainly help you. All right, so you have 3 boxes. Then you have 6 items, as we said before. Now, these items could be anything. Let's say soup. Let's see if can brings up something. All right, there we go. Or baked beans. Baked beans would work. And 1, 2, 3. Oh gosh, 1, 2, 3, 4, 5, 6. All right, there we go. So how do we split up the cans? Well, first of all, let's make this a little bit smaller because that's not realistic scaling for the cans. All right, so now we have our cans. If you're a visual learner, you know you want to split this up into groups of equal groups, 3 equal groups. So there you go, 1, 2, 3. That means there's 2 in each. All right, well, what if I'm not a visual learner, or what if I prefer a faster way? Because one, I'm using a program to draw these fancy pictures. If you didn't have a program like this, and you're doing this on a piece of paper right now, you could just draw boxes, squares for your boxes. And you could do dots for, that's a bad dot, 1, 2, 3, 4, 5, 6. And when you do your dots, you could just split them up into groups of equal groups, 3 equal groups. So now you could see maybe that it's 2 per box. All right. Well, once again, you're still drawing pictures. What is the algebraic or arithmetic way to solve this problem? It is to use mathematical operations, and specifically opposite operations. Let me show you what that looks like. So on the next page, I'm going to rewrite the problem 3x equals 6. And here's how I want you to think of this. And it's still a visual, but I think the visual makes sense. We still want to think of the x as like a box of something. So I'm still gonna bring that up because I think it's really effective when you think of a variable as a box in the beginning. Eventually, this analogy won't work when you're doing more advanced kind of equations. But all right, so this box represents x. I might even write x on the box here. Okay. Now, you're doing 3 times x. So what that means is I'm going to say times 3. Okay, so I'm taking whatever's in the box and I'm multiplying it by 3, and then I get 6. Okay, so take whatever's in the box, multiply by 3, and you get 6. Now, if I want to reverse this process to figure out what's in the box, you're going to just undo the operation that you did on this side. You're going to divide by 3. And watch what happens. 6 divided by 3 gives you 2. So there are 2 items in the box. Whatever those items might be, could be cans of soup, could be baseball bats, could be, I don't know, bottles of water, etc., etc. What's cool about solving the problem this way is that you can check your answer now. Because starting at the top, 2 times 3 equals 6. 6 divided by 3 equals 2. It is a circular thought process that should always get you the right answer no matter where you start. Okay, 6 divided by 3 is 2. 2 times 3 is 6. If you start at the top, you see how that works? You get the same answer, and it's a good way to check. Now, some teachers would show you this. Wait, before I even do that. So they write the original problem, and then since you're dividing both sides by 3, you get x equals 2. Now that's really cool, and that's a great way to solve it. And you can do that. I'm showing you multiple methods because one of these methods might click with you, or a combination of having the visual and this way of writing it might click with you even better. What did we do in this situation? Well, whatever you do to one side of the equation, make sure you do to the other side. So they divided the 3 away and on the left side, and they also divided the right side by 3. So how did we get to x equals 2? Well, this is something I talk about in my other videos, but this is a ninja 1. Ninja. Why is it a ninja 1? Because it's a 1 that's in disguise. Okay, like ninjas try to hide and sneak around and blend into their surroundings so nobody sees them. This is a ninja 1. This is really just a 1 in disguise. So we kind of ignore it, but technically we should be writing it right here. 1x equals 2. 6 divided by 3 is 2. So we'll look at that. You got 3 ways to solve an equation. You can use like a scale analogy, draw the pictures of the scale, and maybe visualize how many items would go in each box, or you could do the circular problem solving chart. I'll have to come up with a fancy name for that. Or you do it the traditional way, which is, this was what I imagine most teachers would show you in an algebra class on how to solve it. And when they want to see your work, they probably want to see this. I am good with any of the ways you show your work. You could show this, you could draw the scales, whatever you wanted, because there is no one way to do anything in life, let alone in math. So any teacher that forces you to always solve this way is not doing you any benefit, because they're not allowing you to be creative and use your mind in as many ways as you can. All right, so that's just dividing, and that's a super simple example. We will, in the next video, do a problem that requires you to do multiplication. Thank you for joining us. Click the link to access the next video on multiplication.